Good morning, this is your Stats Sensei, Mr. Spensei, and we're going to do our introductory activity, hiring discrimination. It just won't fly. The awesome thing about this activity is we cover all 4 units of the course in one exercise. So basically, we're going to collect data, we're going to display and describe data, we're going to figure the probability of that data, and then we're going to make a decision based on that data. Now, I will tell you, this is going to be a longer video because there's a fair amount to it. Um, After this one, the videos should be substantially shorter. So, um, Emirates Airlines is one of the safest airlines in the world and has a 4-star rating. And just so you know, that's outstanding for customer service rating. It took me over 26 hours to make a flight from Boston to San Antonio this past summer. And I won't name the airline because I think that'd be wrong, but I will say that it was an American airline. So it was an American Airlines, but I don't want to name the company. So, however, a few years ago, Emirates Airlines became the subject of a gender discrimination lawsuit. Basically, for the company, things have been going really well. It was growing, and they were looking to hire 25 pilots. And they'd all gone through the training, all had been successful. There were 15 male and there were 10 females for a total of 25. And all the candidates were qualified and had been assured immediate positions after the training. Unfortunately, the economy crashed and the airline was only able to offer 8 positions. Emirates executives decided to use a lottery to determine which of the candidates would be selected. Now, this was done at night. No one was there to watch them. So we don't know what really happened, but supposedly they put the 25 candidate names in a hat and mixed, drawing 8, which would be in a reasonable way to make sure everyone had an equal opportunity. A day later, the managers announced the results of the lottery selection. Of the 8 captains, 5 were female and 3 were male. So 3 out of 8, whereas initially we had 15 out of 25. We had 15 male out of 25, and we had 3 out of 8. And let's just do a couple of little quick probabilities here. And we'll need to do them again later, but 15 divided by the 25. And so about 60% were males. And here we ended up with 37.5%. So a big drop in what they anticipated. So does the situation suggest the selection process was not fair and the female pilots might have been given preferential treatment? And the male pilots said that they were. Who knows why, but they were claiming the females got preferential treatment. Well, the first thing is, how many would you have expected to hire? Well, what I would have done is said, well, 15 over 25 equals X over 8, set it up as a proportion, and I find out that 4.8. Or I could have said that 60%, which just came from the 15 over 25, equals 4.8. So in the long run, on average, we'd expect to hire 4.8 male captains. Of course, we couldn't hire 4.8, so we'd either have 4 or 5. So somewhere between 4 or 5 is what we would anticipate to happen. Only 3 were hired. Thus, it seems like the women may have been shown preferential treatment. So guess what? The men sued and the case went to court. The defendant was Emirates Airlines. In an American court of law, what are we supposed to believe about the defendant prior to the court case? Well, we presume that the defendant is innocent until proven guilty. So basically, we have to believe that the airline is innocent initially. What does the prosecution claim about the defendant? Well, they claim they're guilty. So what do they do to prove that or show that? They provide evidence. Well, the question in this case is, do we have any evidence? And the answer is, yeah, we do. We have some evidence. We thought they'd hire 4.8 and they only hired 3. So there is some evidence. So the question is that enough? So we all believed and thought that there'd be more male pilots that should have been hired and the process was fair. But in statistics, we should ask, do the results of the lottery provide convincing evidence? Because in a court of law, it's not do you provide some evidence, do you provide convincing evidence? For instance, we know the murderer was a male or the murderer was a human. Well, Mr. Spencer is a human, therefore he did it. Not enough evidence. We know that the murderer was a male. Mr. Spencer is a male, therefore he did it. Not enough evidence. Half the population is male. Oh, we know that the murderer lives in San Antonio. And he's like, well, more than a billion people live in more than 1 million people live in San Antonio. Still not enough evidence. But at some points, there becomes enough evidence, and you go, you know what? Seems pretty likely that that's the guilty person. So the question is, in our case, is a selection of 3 or less men very unlikely to have happened by random chance alone? So, or is that enough evidence to say that they're guilty? Well, we need to figure out what random chance is. So I need to talk to you about flipping a coin. So consider coins a random chance. If you had 2 quarters and flipped them both at the same time, how many heads would you expect? Well, there's a 50% chance of getting a heads. If I flip 2, then I would expect to get 1. And by the way, e to the x is just a fancy way of saying expected. It's also another way of using the mean, and we'll talk about that much more when we get to probability. So in the long run, if we flip 2 coins, we'd expect to have 1 head on average. But my question is, if we were to flip 2 coins, would you really freak out if you flipped both quarters and ended up with 2 tails and 0 heads instead of the expected 1 tail and 1 head? And I'm going to say probably not. Consider this. You know that the outcome is likely to vary from flip to flip, and that variation is due to random chance. And that was the random chance we're talking about. In fact, we know that if we list all the possible outcomes for the 4 coins, we could end up having the following. A tail, that would be 0 heads. A tail and a head, that's 1 head. A head and a tail, that's 1 head. And a head and a head, that's 2 heads. All right? But we really expected only 1 head. Well, how many times did that happen? That happened 2 out of 4, or 50% of the time. So 50% of the time that we end up with actually 1 head, which means 50% of the time we end up with something completely other than 1 head, whether it's 0 heads or 2 heads. So back to the court case. Our goal is to simulate the airline scenario to determine how likely or unlikely it is that 3 or fewer male pilots would have been selected by random chance alone. Basically, we are trying to determine whether the event is extremely likely or unlikely. And whether or not the findings we can use that to determine whether the airline was guilty of gender discrimination. To test to see if the lottery was fair, we're going to run a 10-sided dice simulation. So basically, I have 10-sided dice, and they look like that, and they're numbered with the numbers 1 all the way, 0 all the way to 9. And we're going to let the 0 represent a 10. Now, here's what I want to tell you about that. For 10-sided dice, and I actually have 10 of them right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to roll them to determine how likely they are. So it turns out we'll need 8 of the 10-sided dice. Those 8 dice represent the number of captain's positions being hired. So I'll have 8 dice, and there's my 8. And I have these numbers. And it really doesn't matter what numbers we choose, but because 15 out of the 25 or 60% were males, we need to have 6 numbers represent males. You may choose 1 through 6 or whatever you choose. I'm going to choose 0 through 5. So 1, 2, 3, 4, 5, 6. That's 6 out of the 10 numbers. That gives me my 60%. All right. So suppose I roll the 8 dice with the results which, and I got these results. I got a 0, a 0, a 1, a 3, a 4, a 7, or 8, 9. Well, if I got those, 1, 2, 3, 4, 5, that means I would add 5 males, and I'd go mark a tally mark by the number 5. So I'm going to go ahead and do this. It's going to take me a moment. I'll do a first couple, then I'll pause it and come back to it. So I'm going to roll, and I go, okay, the 7's a woman, the 7's a woman, the 7's a woman, and I have 1, 2, 3, 4, 5. So by the number 5, I'm going to mark a single tally mark. I'll roll again. That's a 9. That's an 8. And these 1, 2, 3, 4, 5, 6, I happen to have 6 males. So make a tally mark by 6. I roll again. That's a 5, by the way. And it turns out I have a 7 and an 8. So 1, 2, 3, 4, 5, 6. So I do that again and make another tally mark by the 6. Well, I'm going to keep doing that. So I'm going to put this on pause for just a second. I know I have 5 times written here, but due to the size of my class, I had 7. We did it 7 times. But when I did it 7 times, I ended up with twice I had 6 men. 3 times I had 5 men. 1 time I had 4 men, and 1 time I had 3 men. Then we had the entire class plot this out on a graph sheet. Well, I simulated this, and I simulated this with 120 using a computer applet, and I'd simulate it with 120. And when I did that, this is 1, and this is 3, and we wanted to know how often we had less than 3. So I was looking for the times that we had less than 3. Well, less than 3 is or 3 or less, I should say, are these values. And it happened 23 out of 120 times. That's how many times it happened on a simulation. I did several others as well, but that was probably the most common one, was 23 out of 120. So let's continue on with our questions. Based on the scenario, what evidence is of discrimination? Well, the airline hired only 3 men, which is less than the 4.8 that was expected. That's the evidence we have. So based on the class results of the simulation, what's the chance, the probability we have 3 or fewer males randomly selected? Well, when we ran a totals for the entire class after we plotted everybody's data, we ended up with 23 out of 120. So 23 out of 120, and that's about 19.17%. So 19.17%. So I look at that and I go, well, is that rare? Is that unusual? And it's less than half. So that's not real common. But on the other hand, is that really rare? Well, in statistics, we compare to 5%. If it's less than 5%, it's rare. So in this case, does our simulation provide convincing evidence? And the answer is no, because our probability of it happening by random chance, probability of having it happen by random chance was 19.17%, which is greater than 5%. Also, to put in perspective, if you saw a truck on the road, would you consider that unusual? And no, trucks are fairly common. In fact, about 19% of vehicles on the road are a truck. So consequently, we would not consider it uncommon. It needs to be 5% or less for us to consider it to be uncommon. So that was our experiment and collecting in on, and in the court case, just so you know, the men lost the court case. They were just considered to be whining. It could have happened by random chance. There was nothing unfair that would have been shown just based on the data. So how did we cover the major themes in the course? Well, we used a simulation based on the fact that 60% of the qualified candidates were male. So we used a simulation to collect our data. We created a dot plot of our findings that looked like this. Matter of fact, we can talk about our center, and our center is somewhere probably about 5. And we thought we were anticipating it to be 4.8, but our center is about 5, so that's our center. Another thing that we know is we can talk about the spread, how spread out the data is, and for that we can use the range. And in this case, we had one time we had 8, and our lowest is 1. And range, if you remember from middle school, equals the highest minus the lowest. So in our case, our dot plot, 8 minus 1 is 7. Our range is 7. So now we've not only collected the data by simulation, we made a dot plot to display it. We talked about the center, and we also talked about the spread. So we've displayed and described it. We figured our probability was 19.17%. And some people, and you go, do I need to write it as a percent? Generally speaking, we talk in percent, so we talk about that. But if you wrote the probability is 0.1917, because this is the probability statement, would be like this. That's the same thing. We'll take either one. And then the question is, was there some convincing evidence that the selection process was unfair? And the answer is we had some evidence, but not convincing evidence, not enough for a court of law. So the answer was no. Based on our simulation, we conclude that by random chance alone, we'd select 3 or fewer for the pilots to be male, fewer men of the pilots, 19.17% of the time, which is not less than 5% and would not be considered unusual. And guess what? We just covered the entire course. We went through all 4 topics. Now, obviously, there's a lot more to learn about those four units, but that's the entire course, the entire 4 units. In our next video, which will be a bit shorter, we're going to apply some of the things we learned here to a question that showed up on an AP exam just a couple of years ago. All right. Thank you for watching. I hope to see you on the next one.